Hi there, my name is Anna Lushkovsky. This is the Architectural Technology Lesson 2, which is about mechanics. So I'll explain to you briefly the content of the lesson, and if you've got further queries you can contact me and discuss it in more detail. So it mainly deals with mechanical issues and such as weight of building materials and persons, and weight of vehicles and areas that are mainly being used by humans, or cars and so on and so forth, because to be able to bear the load of this weight, the building materials, they need to be constructed in a certain way to have a certain density and tightness and thickness or compactness. Say for example, concrete and steel can bear more weight than polystyrene or timber or glass and things like that. So this is important to construct buildings that are not going to collapse, or if you walk on them, that they're not going to fall or don't crack or anything. So the first thing is the weight of building materials in itself, which is calculated by kilonewton divided by meter multiplied 3 times square meter volume. So obviously, or it can be in kilogram divided by decimeter cubic, or tons divided by meter cubic. So this is the weight of building materials, how it is defined in biophysics. So this is obviously important to be able to construct a building that will be able to stand a certain weight of persons, depending on the usage of the building. If it's a residential usage, then obviously will be a family of 3 people living there. But say if it's a community building such as a library or a community house, and there will be a certain number and group of people, so then the building needs to be able to bear that load of traffic. Same like other buildings like airports or motorways need to be constructed in a certain way. So this what these calculations are about. And then the next part of it are foundations, and how much the weight foundations can carry. So a geotech engineer will do a report about the foundation, if it's clay or sand or what it is, and then you will be able to calculate or design the footings. And then there are such factors as the weather conditions, and say the snow load. As you know, that the snow load on the South Island in New Zealand is higher than on the North Island, and so we need to be able to calculate or just select materials, building materials, like for example the roof cladding, that need to be able to bear this weight of the rainfall density in snow, or a certain width of overhang and things like that. And then obviously in engineering there are such important things like force, so pressure or moment that something could just bend or rotate. And say if you design a column, needs to be a certain diameter, or have a reinforcement and things like that. And there are nice formulas I could show you. To be able to calculate this and design safe buildings that are not going to yeah, stand an earthquake and all sorts of conditions. Yeah, so this is what the mechanics of building mechanics is about. Yeah, so here are certain table which gives you all the construction values for building materials. Thank you.